Hi, my name is Shahroz Ahmed, and in this video you're gonna learn about trigonometry. It's a topic of IB Maths standard level. So in this trigonometry topic we have to discuss the trigonometric ratios first of all, like sine, cos, tan, and then we'll find out the values of sine, cos and tan for some specific angles, and then we will work out we will see how the trigonometric identities work, and at the end we will see the sine and cosine rule. So let's start off with the trigonometric ratios in the beginning. So for the trigonometric ratios, for example, we have a right angle triangle. Let me just draw it over here. So that's a right angle triangle, and there's an angle over here. This angle is represented by theta. So the side that is opposite to this angle, it will be called as opposite, and this side will be called adjacent, and the largest side of this triangle will be called the hypotenuse. So if we have to work out sine of theta, then we will say that sine of theta is equal to the opposite over hypotenuse. Opposite over hypotenuse. If you want to work out the cos of theta, alright, so before writing it, I want to let you know that this sine theta, cos theta and tan theta, they are called the trigonometric ratios, and we will calculate these trigonometric ratios by the help of this right angle triangle. This is a right angle triangle which has one angle equals to 90 degrees. So cos of theta is equal to adjacent over hypotenuse. Then we'll have the tan theta. So tan theta is equal to opposite over adjacent. So these are the three trigonometric ratios that you're gonna use in the right angles triangles. Remember that these ratios are only applicable on the right angle triangles. If the angle is not right angle triangle, then you cannot use these trigonometric ratios to work out your angles or the sides. Mainly we use these trigonometric ratios to work out the lengths of the triangle or the angle in the triangle. All right, okay, now let's see some of the values for the sine, cos and tan. So we will see the values for sine theta, cos theta and tan theta for some specific angles. Let's suppose the angles are 0 degree, 30 degree, 45 degrees, 60 degree, 90 degree and 180 degree. So these are some of the specific angles that for which we should know the values of sine, cos and tan, because there are some questions that come in the section of non-calculator where we have to use the trigonometric ratios, and we should know the values for those trigonometric ratios for these specific angles. So let's start off with sine. Let me just write down, make a table of it, and then I'll just write down all the values for these angles for the sine, cosine and tan. Alright, so here I have drawn the table for the values of sine, cosine and tan for some different angles. Before doing that, I want to let you know that tan theta is equal to sine theta over cos theta. Okay, so tan theta is basically the ratio of sine theta over cos theta. That will help us in finding out the values for tan. So starting off with sine. So sine of 0, it's 0. Sine of 30 is 1 over 2. Sine of 45 is 1 over under root 2. Sine of 60 is under root 3 over 2. Sine of 90 is 1. And sine of 180 is 0. Now in order to write down the values of cos of 0, we'll start off from the values of sine from here. So let's suppose if sine of 0 is 0, then cos of 90 is 0. If sine of 30 is 1 over 2, then cos of 60 is 1 over 2. If sine of 45 is 1 over under root 2, cos of 45 is also 1 over under root 2. Sine of 60 is under root 3 over 2, so cos of 30 will be equal to under root 3 over 2. And sine of 90 is 1, so cos of 0 is 1. Basically cos is opposite to the sine. The values of cos for these angles are opposite for the sine. So let me just fill it up. So cos of 0 is 1, cos of 30 is under root 3 over 2, cos of 45 is the same as of sine of 45, and the cos of 60 will be equal to 1 over 2. Cos of 90 is 0, and cos of 180 is -1. Alright, now let's see for the tan. So tan of 0, as I have told you that tan theta is equal to sine theta over cos theta. So tan of 0 is equal to 0 over 1. Like this is sine theta and this is cos theta. So sine theta over cos theta will give us the tan theta. So the tan theta will be equal to 0 over 1, so it will be 0. Tan of 30 will be equal to 1 over 2 divided by under 3 over 2. So that would be equal to 1 over under 3. Tan of 45 will be equal to 1 because sine of 45 is equal to 1 over under 2. Cos of 45 is the same as well. So once we divide it, we'll get 1. And then tan of 60 is equal to under 3 over 2 divided by 1 over 2. So that will be equal to under 3. Tan of 90 will be equal to 1 over 0. So 1 over 0, like something divided by 0 is undefined, so it's undefined. And the tan of 180 will be equal to 0. So this is the table that you can make in order to remember the values for the sine, cos and tan for these angles. I have mentioned these angles because these are the most common angles that are used in the non-calculator questions. So you should know by yourself the values of these angles. Okay, so this is done. Now let's see the values of sine, cosine and tan in different quadrants. Alright, so now we have to see the values of sine, cosine and tan in different quadrants. So let's suppose we have an angle. This is the first quadrant, by the way. That's the second quadrant. That's the third quadrant. That's the fourth quadrant. And the angle at the center is 0. This is 0 over here. This is x-axis. This is y-axis. Now let's suppose we have the angle in the first quadrant. So remember that when we have to measure the angle, we always measure from the positive x-axis and we move in the anti-clockwise direction. So this is the angle. So if we have the angle in the first quadrant, the values of sine of this angle, cosine of this angle and tan of this angle will always be positive. So in the first quadrant we have sine, cosine and tan. All of them will give us a positive value. For example, let's suppose this angle is 45 degrees. So sine of 45, cos of 45 and tan of 45 will give us positive values. Okay, now let's see the second angle. I'll name this as theta 1. Now let's see the second angle over here. So let's suppose we have the angle in the second quadrant. Let's suppose this angle is theta 2. So this angle will give us, in the second quadrant, only sine is positive. Cosine will be negative and tan will be negative. For example, if this angle is 150, so sine of 150 will give us a positive number, but cos of 150 and tan of 150 will give us negative values. Now let's see in the third quadrant. So in the third quadrant, tan is positive, but sine and cosine will give us the negative values. So if we have the angle in the third quadrant, the tan of that angle will be positive, but the sine and cosine of that angle will be negative. If the angle is in the fourth quadrant, then we will have cos as positive, but sine and tan of that angle will give us the negative values. So remember that in the first quadrant, sine, cosine and tan all are positive. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive. In the fourth quadrant, only cosine is positive. So if we have the angle in the particular quadrant, we have to see where we will get the positive values and where we will get the negative values for sine, cosine and tan. So this will help you in doing the exam questions. That's why I have explained you this quadrant and the concept of the values of sine, cosine and tan in different quadrants. So in order to make it simple, I'll just remove the ratios with the negative values so you can remember it easily. So we have in the first quadrant all positive, so I'll just write it as all positive. In the second quadrant, sine is positive. In the third quadrant, tan is positive, and in the fourth quadrant only cosine is positive. So this is the concept that you have to remember for angles in different quadrants. After this one, we have to discuss some of the trigonometric identities that are mostly used in solving the different questions related to the trigonometry. I'll just explain them. So let's see different trigonometric identities. Alright, so now we have to discuss the trigonometric identities. So first of all, we'll discuss some basic trigonometric identities, and then we'll see the double angle identities. So in the basic trigonometric identities, we have sine square theta plus cos square theta equal to 1. This is the first basic trigonometric identity. The second one is 1 plus tan square theta is equal to secant square theta. The next one is 1 plus cot square theta is equal to cosecant square theta. Before moving forward, let me tell you that secant theta is simply the reciprocal of cos theta, and cosecant theta is the reciprocal of sine of theta. Okay, so these are some of the basic trigonometric identities. Now in order to see the double angle identities, it's like this: sine of 2 theta is equal to 2 sine theta cos theta. Then comes cos of 2 theta, that would be equal to cos square theta minus sine square theta. We can also write it as 1 minus 2 sine square theta, or we can also write it as 2 cos square theta minus 1. So this is for cos of 2 theta. Now there's another one that is for tan of 2 theta. So tan of 2 theta is equal to 2 tan theta over 1 minus 2 tan square theta. So these are some of the double angle trigonometric identities that are most commonly used in the questions. So you have to just remember them, and wherever they're applicable, you have to use them to get to reach to your answer. So after these trigonometric identities, we have to discuss the sine rule and cosine rule. Alright, so sine and cosine rule. So we use the sine and cosine rule in order to measure the angle or the lengths of a triangle, and mostly we use the sine rule and cosine rule on such triangles where the triangle is not a right angle triangle. So for example, we have a triangle over here that is not a right angle triangle. Here I'm going to draw a triangle. So let's suppose this side is A, this side is B, and this side is C. Now the angle opposite to side A will be called the angle A. I'll represent the angle with capital alphabets. So the angle in opposite to side B will be B, capital B, and the angle opposite to side C is capital C. Now in order to relate these sides and angles, let me just write down the first rule, that is the sine rule. So sine rule says that it will be related by sine A over A equals to sine B over B equals to sine C over C. So this is basically the sine rule. So according to our need in the question, we can use any pair from this equation. Either we can use this pair or this pair or this pair. Alright, now the next one is the cosine rule. So in cosine rule says that a square is equal to b square plus c square minus 2bc cos of a, or we can also use it as b square equals to a square plus c square minus 2ac cos of b, or we can write it as c square equals to a square plus b square minus 2ab cos of c. The capital alphabets are representing the angle and the small alphabets are representing the sides. So this is the sine rule and cosine rule that we can use in our questions to work out the unknown sides or the angles in such triangles that are not right angle triangles. If the triangle is a right angle triangle, then we can simply use the trigonometric ratios like sine theta equals to opposite over hypotenuse, cos theta equals to adjacent over hypotenuse, and tan theta equals to opposite over adjacent. But for such triangles which are not right angle triangle, we have to use sine rule and cosine rule. So this is it for the concepts of trigonometry. And now we'll move on to some exam related questions. Alright, so for the questions, I'm following this website revisionvillage.com that most of the students for IB maths follow. So it has all the questions from easy level to the medium to the hard. So what I'll do is I'll do a one question from the easier difficulty level, and then I'll do one from medium level question, and I'll do one a hard level question. So let's start off with this easy question. So it says let f of x equals to a sine of bx, where x belongs to the real number. The following diagram shows part of the graph of f. I have not explained this concept in the explanation part, but this is very easy concept. I'll just show you how. So in part A, it says write down the amplitude of f. So if we have a trigonometric function like a sine of bx, so the coefficient of the sine function that is over here, that is a, it represents the amplitude. All right, and this whole thing represents the angle, or we can say the time period. So for this one, in order to find out the amplitude of f, it's quite simple. That is a. So a is basically the amplitude, and we have to work out the amplitude. So the amplitude is basically the distance from the mean position to the extreme position. So this is the mean position, the horizontal line in between this graph. So the distance from the mean position to the extreme position is 3. So the amplitude for this one is equal to 3. And as I've just told you that the a is representing the amplitude, so the value of a will also be equal to 3, because 3 is the amplitude. All right, so now let's move on to part bi. So in part bi, it says write down the period of f. Period means the time period. So time period is basically, it is the angle covered for completing one cycle. So the cycle of this wave starts from here. So from here to this point, it's half cycle, and from here to this point is the full cycle. So the period is equal to pi by 2, because it has taken the angle of pi by 2 to complete one cycle. Pi by 2 is basically the angle in radians, and let me tell you briefly that 360-degree angle is equal to 2 pi radians, or we can say 180-degree is equal to pi radian, and 90-degree is equal to pi by 2 radians. So this is how you can convert the angles from the degrees to the radians. Anyway, coming back to the question, so write down the period of f, so that is pi by 2. Now over here it says find the value of b. So you see b is over here, it's sine b of x, a sine b of x. So in order to get the value of b, what we have to do is b times the time period should be equal to 2 pi. Why 2 pi? Because a complete cycle should be equal to 360-degree, and 360-degree in radians is equal to 2 pi. So in order to work out the value of b, you will multiply b with the time period and put it equal to 2 pi. So the value of b will become equal to 2 pi over the period, that is pi by 2. Pi by 2. So pi will get cancelled, and the value of b will become equal to 4. So 4 is the answer for the value of b. So this is how you'll work out question related to the trigonometric graph. This is the graph for the sine function. All right, so here we have another question. It's a medium difficulty question, so let's see how it goes. So in the question it says given that sine of x equals to 4 or 5, where x is an obtuse angle. Remember, obtuse angle is the one that is greater than 90 degrees. Find the value of cos of x, cos of 2x, and tan of 2x. All right, so cos of x we have to work out. Okay, so sine of x will be equal to 4 or 5. So x will be equal to sine inverse 4 over 5. So when you put this into the calculator, we'll get the answer equal to sine inverse 4 over 5. We will get 53.13 degrees. But this angle is in the first quadrant. It's the acute angle. We have to find out the relevant obtuse angle. So it's the answer is positive. So in order to understand it, we will draw a y-axis and an x-axis. As I've told you that sine of theta is equal to opposite over hypotenuse. So if we draw it over here, if the angle is over here, let's suppose this is x, then this side will be the opposite and this will be the hypotenuse. So the opposite will be 4 and the hypotenuse will be 5. If we, because this angle is greater than 90, so this must be over here. This angle will be here. So in that way, this side is 4 and this side is hypotenuse is 5. Now as we have got this angle equals to 53.13, so this angle will be equal to 53.13. So in order to find out the original angle will be starting from the positive x-axis and moving in the anti-clockwise direction and reaching over here. So the original angle will be equal to 180 minus 53.13. So 180 minus 53.13, that's the original angle. That would be equal to 126.87 degrees. Now in part A, we have to work out cos of x. So as we know that cos of x is adjacent over hypotenuse. So if this is opposite, this is hypotenuse, so this side will be the adjacent. In order to find out this side, we will use the Pythagoras theorem. That would be equal to 5 square minus 4 square whole under root. So it will be 25 minus 16 whole under root, that is under root of 9, that is equal to 3. So this will be 3 over here. Now cos of x will be equal to, okay, now because it is to the negative x-axis, so this length will be considered as negative. And as we know that cos of theta is equal to adjacent over hypotenuse, so our adjacent is -3 and hypotenuse is 5. So cos of x will become equal to -3 over 5, and this is true because cos is negative in the second quadrant. Now we have to work out the value of cos of 2x. So in order to find out the cos of 2x, as we know that our angle is 126.87, this is x, so 2x will become equal to 253.74. So this 253.74 will be in the third quadrant, like over here. All right, so we have to work out the value of cos of 2x. So we can do it simply by using the trigonometric identity. There's no need to draw it by using to find it by using this quadrant. So as we know that cos of 2x is equal to cos square x minus sine square x. So we have the value of cos of x, we have the value of sine of x. We'll just insert it over here and we'll get the answer. So cos square x is -3 over 5 whole square, and sine square x is 4 over 5 whole square. So this will give us the answer for cos of 2x. I'll just put that into the calculator and solve it that in one go. So the answer that I have gotten is -7 over 25. So -7 over 25 is the answer for cos of 2x. And now in part C, we have to work out the value of tan of 2x. So as I've told you that tan theta is equal to sine theta over cos theta. Now over here we have to work out the value of tan of 2x, so we can write it here as tan of 2x is equal to sine of 2x divided by cos of 2x. We have the value of cos of 2x, but we do not know what's sine of 2x. So in order to find it out, we will use another double angle identity that says sine of 2x is equal to 2 sine x cos x. So sine of 2x will be equal to 2 times, now sine x is 4 over 5 and cos x is -3 over 5. So sine of 2x will become 2 times 4, that is 8. 8 times minus 3, that is minus 24. And 5 times 5 is 25. So it's minus 24 over 25. Now tan of 2x will become equal to sine 2x, that is minus 24 over 25, divided by cos of 2x, that is minus 7 over 25. And when we'll divide it, this will get cancelled, and my answer will be equal to minus 24 over minus 7. That will be simply 24 over 7. So that will be the answer for tan of 2x, 24 over 7. And for this one, it's minus 7 over 25. So this is how you can do the working in order to get the values for cos x, cos 2x, and tan 2x. Now let's move on to a hard level question. Alright, so here we have a hard level question. So in this question it says the following diagram shows triangle ABC. Point D lies on AC so that DB bisects angle CBA, which means that these two angles are equal. Now the area of the triangle ABC is 3 centimeters square. Find the value of x in the form of a over b, where a and b are the positive integers. So we have to work out the value of this side. For that purpose, we have to know the formula in order to find out the area of the triangle. So there's a formula in order to find out the area of triangle, and the formula is 1 over 2 AB sine C. For example, if you have a triangle, this is side A, this is side B, this is side C, this will be angle C, this will be angle B, and this will be angle A. If you have to work out the area of this triangle, we need two sides and the angle between them. So that's why it will be called AB sine C times half. So in this case, I'll consider this as my A, this as my B, and the angle between them as C. So the area of this triangle will be equal to 1 over 2 AB, like 1 over 2 times A is 2 under root 7, B is x, and sine of 2 theta. Okay, because this is theta, so theta plus theta will become 2 theta. So the area will become equal to 1 over 2. So this 2 will get cancelled, and we'll have under root 7 times x times, now sine 2 theta can be written as 2 sine theta cos theta. So we have the value of sine theta, but we do not have the value of cos of theta. So in order to work it out, we will use a trigonometric identity, that is sine square theta plus cos square theta equals to 1. So I'll put the values over here and work out the value of cos theta. So cos theta will become equal to 1 minus sine square theta whole under root, because that was square over here. So in order to remove the square, we have to square root both sides. So on the left side I'll have cos theta, on the right side I'll have square root 1 minus sine square theta. Anyway, so it's like 1 minus 3 over 4 whole square equals to under root 1 minus 9 over 16. So that would be equal to 7 over 16, under root 7 over 16. So when we'll simplify it, so I'll get cos of theta equals to under root 7 over 4. So this is the value of cos of theta. I'll remove the rest of the working that I've done so that I can get some more space. All right, so under root 7 times x times 2 times, now sine theta is 3 over 4, and cos theta is under root 7 over 4. Now in the question it has been told that the whole area of this triangle is equal to 3 centimeters square. So I'll put it equal to 3, and from here I'll make x as my subject, and I'll get the value of it. So it will be like 3 equals to x times under root 7 times under root 7 is 7, 7 times 3 is 21, divided by, and there's also 2 over here. Okay, so 2 times 3 is 6, 6 times 7 will be equal to 42, and 4 times 4 is 16. So it'll be like 3 equals to x times 42 over 16. and from here I'll get my value of x, that will be equal to 3 times 16 over 42. So the final answer for x will be equal to 8 over 7. So I have given the answer in the form of a over b. So the value of a is 8 and the value of b is 7. A equals to 8 and b is equal to 7. So this is how you can work out the question, like the exam related question. So it's not necessary that you'll be using the concept that I have told you in the introduction. There are several other concepts. I've just told you the basics of for trigonometry in the concept thing, but you will learn by doing as more questions as possible. All right, so this is it for this video. I hope you like it. Thank you so much.